Hello students, welcome to Swapna physics classes. In this class I am going to explain you one more important essay question for your TS second year IPE examination. TS second year IPE physics examination, and the question is explain the formation of the stationary waves in stretched strings and hence deduce the laws of transverse waves in stretched string. Consider a string which is stretched between the two rigid boundaries. The ends of the string is fixed. Now let's plug this string and leave it. What happens? The string starts vibrating. This string starts vibrating about its mean position. That means the particles or the elements of this string oscillates. About its mean position. Okay, the particles starts oscillating about their mean position. Okay, and what happens? The wave generates, a transverse wave will generate along this string. As I plugged in between these two rigid boundaries, what happens? Here two or more waves are generated, and one is along positive x-axis and the other is along negative x-axis. One is along positive direction and the next one is along negative direction. Okay, what happens? This wave will move along this direction and get reflected at this boundary. This wave gets reflected at this boundary and will move along this length of the string and gets reflected at this boundary. And this wave will reflect at this boundary, and will move along the length of the string and gets reflected at this boundary. This will continue until a stationary or standing wave is formed. Okay, and we know that the standing wave or a stationary wave will form whenever the two waves which are superimposing over each other, having same phase, same angle of frequency, and same time period, but different amplitude. The standing wave or a stationary wave will form whenever the two waves which are superimposing each other, having same phase, angular frequency, time period, but of different amplitude. I will explain this point in this lecture only. Don't get confused. Okay, and what happening here? The two waves which are superimposing each other forms a stationary wave. Okay, whenever these two waves have the same phase, same angular frequency and same time period, after superimposing forms a stationary or standing wave. Okay, and what happening here? After reflection, one of the wave will travel along the negative direction and this wave is traveling along the positive direction, and the displacement relation for these waves will be, let's see, the wave which is traveling along positive direction will have the displacement relation as y1 of x comma t is equal to a sine of kx minus omega t. And the wave which is traveling along negative direction or negative x-axis will have the displacement relation as y2 of x comma t, which is equal to a sine of kx plus omega t. These two waves will superimpose to form a stationary wave. And according to the superposition principle, y of x comma t is equal to y1 of x comma t plus y2 of x comma t. According to the superposition principle, the displacement relation, the resultant displacement relation is y of x comma t equals to y1 of x comma t plus y2 of x comma t. Now you just substitute these two equations in this equation. Okay, y of x comma t is equal to y1 of x comma t is a sine of kx minus omega t plus y2 of x comma t is a sine of kx plus omega t. You just observe carefully from trigonometric relations. Sin a plus b plus sin a minus b is equal to 2 sin a into cos b, 2 sin a cos b. Okay, this relation is similar to this equation. Okay, here you have a sin of kx plus omega t in place of sin a plus b, and in place of sin a minus b you have a sin of kx minus omega t. Okay, if you relate both these equations and taking common this a okay, I'm taking a as common, you will have 2 sin a, what is a here? Kx, 2 sin kx into cos b. What is b here? We have omega t. Okay, therefore y of x comma t will be equal to 2a sin kx cos omega t. This is the resultant displacement equation according to superposition principle. Okay, you just copy this. Here I am considering this 2a sin kx as the amplitude. Amplitude a is equal to 2a sin kx. Therefore, the displacement relation is equal to y of x comma t is equal to a cos omega t. Okay, and we know that the sine function, listen carefully, the sine function always vary in between -1 and +1. తెలుసా మీకు ఇది? I will explain, you just don't worry. Okay, at this position sin 0 will be 0, we know that, and for 90 degrees sin 90 is equal to 1. Okay, and for 180 degrees sin 180 is equal to 0, and sin 270 is equal to -1. Do you know this? Here the sine function is varying in between -1 to +1. But the amplitude A is always positive. This will be always positive. I will explain why. Whenever a wave is produced, whenever a wave is produced, the elements of the string will vibrate with the different amplitudes. Here this particle is having maximum displacement when you compare with the remaining particles or elements of the string. Okay, and this is the maximum displacement, which is nothing but amplitude. Maximum displacement is nothing but amplitude. And here we are saying that the amplitude is maximum. Amplitude is maximum. That means it will be always positive. It will be along negative direction as well as positive direction. It is along negative axis as well as positive axis, but it will be always maximum. Okay, therefore the amplitude is varying in between 0 to +1 only. Okay, this minus sign or plus sign indicates the direction only. Okay, it will have always maximum value. Okay, now shall I rub this? Did you copy it? See here, if you observe carefully, for minimum amplitude, you will have nodes, and for maximum amplitude, you will have antinodes. If you observe the waveform, okay, here the amplitude is minimum. At these positions the amplitude is minimum, and these points or these positions are known as antinodes. These positions are known as nodes. These positions are known as nodes. And at these points amplitude is maximum, and these positions are known as antinodes. Okay, and the amplitude always varies from 0 to +1. Okay, if the amplitude is equal to 0, that means the sin kx is equal to 0. Okay, and if the amplitude is equal to 1, sin kx value will be equal to 1. And for sin theta to be equal to 0, this theta must be equal to n pi. How? I will explain. Okay, here sin 0 is 0, sin 180 is also equal to 0, and sin 360 is also equal to 0. Here sin 180 is nothing but sin pi is equal to 0, sin 2 pi is equal to 0, again sin 3 pi is equal to 0, sin 4 pi is equal to 0, and so on. That means here I am considering this n as an integer, and the n value is equal to 0, 1, 2, and so on. Okay, if this theta is equal to n pi, okay, then sin n pi will be equal to 0. Right? So from these two equations, if you observe these two equations, here in place of n pi you are having kx. Therefore this kx is equal to n pi. Okay, and this x equals to n pi by k, and we know that since k is equal to 2 pi by lambda, we had already derived this equation in our previous lecture. For the derivation part, you just go through our playlist of waves chapter. Playlist ఉంది కదా wave chapter అక్కడ చూడండి, దీని డెరివేషన్ ఉంటుంది. ఓకే, నో సబ్స్టిట్యూటింగ్ ఇన్ దిస్ ఈక్వేషన్ n pi by 2 pi by lambda. Therefore x equals to n pi cancel. Okay, n lambda by 2. N lambda by 2. At these positions, n lambda by 2 position, we will have nodes. Copy this. And the n value is from 0, 1, 2, 3, so on. If you substitute here in this equation n values, x will be equal to, for 0, x is 0, and for n equals to 1, x is lambda by 2, and for n equals to 2, x is 2 into lambda by 2, and for n equals to 3, x is equal to 3 into lambda by 2, and so on. If you observe carefully, the distance between any two successive nodes, the distance between any two successive nodes will be equals to lambda by 2. Okay, the distance between any two successive nodes will be always lambda by 2. Okay, copy this. And these are the positions of nodes. First node is at x equals to 0 position, next is at x equals to lambda by 2 position, and next one is x equals to 2 lambda by 2 position. 2 lambda by 2, 3 lambda by 2, 4 lambda by 2, 5 lambda by 2, and so on. These are the positions of nodes. And coming to the positions of antinodes. Position of antinodes. Let's derive the position for antinodes. Okay, and whenever the amplitude is equal to 1, sin kx is equal to 1, and this sin kx will be equal to 1 whenever this kx value is equal to n plus 1 by 2 times of pi. N plus 1 by 2 times of pi. See, at these positions you will have sin theta is equal to 1. Okay, and theta will be pi by 2, 90 degrees. Okay, theta for 90 degrees, sin 90 will be equal to 1, and this is 270, 360 plus 90. Okay, so 360 plus 90, sin 360 plus 90, and 360 plus 180, and so on. Okay, this will be equal to n plus 1 by 2 times of pi, and the n value is from 0, 1, 2, 3, and so on. Okay, and this x is equal to n plus 1 by 2 from this equation into pi by k, and we know that k is equal to 2 pi by lambda. On substituting this value in this equation, the positions of antinodes will be equal to n plus 1 by 2 times of pi into lambda by 2 pi. Pi get cancelled. Okay, therefore x is equal to n plus 1 by 2 times of lambda by 2. Okay, at these positions we will have antinodes. Okay, let's check this. For n equals to 0, x is equal to 1 by 2 into lambda by 2, and for n equals to 1, x is equal to, if you substitute 1 plus 1 by 2 is 3 by 2 into lambda by 2, and for n is equal to 2, x is equal to 2 plus 1 by 2 is 5 by 2 into lambda by 2. if you observe carefully, the distance between any two nodes, or the distance between successive antinodes, sorry, not nodes, the distance between any two successive antinodes will be equal to lambda by 2. Okay, and the first antinode is observed at this position, okay, that is 1 by 2 into lambda by 2, and the next antinode is observed at 3 by 2 into lambda by 2, and next one is at 5 by 2 into lambda by 2, and so on. These are the positions of antinodes. And now let's find out the frequencies at which stationary waves are formed in a stretched string. Keep the heading frequencies at which stationary waves are formed in a stretched string. You have to remember one point, always the distance between any two antinodes or the distance between any two nodes, successive antinodes or successive nodes, will be always equal to lambda by 2. Okay. Keep the heading frequencies at which stationary waves are formed in a stretched string. Okay, and we know that frequency nu is equal to v by lambda for any medium. Depending on the velocity, frequency will be equal to v by lambda. Frequency of the wave in any medium will be equal to v by lambda. The frequencies will always depends on the velocity of a wave in a medium. Okay, and we know that the nodes are formed at positions n lambda by 2, right? And the first node is formed at n equals to 0. At n equals to 0, x is equal to 0. And I am considering the length of the string as L. I am considering the total length of the string as L. Why? Because x is equal to L minus 0 is equal to L. The length of the string is L. And for x equal to L, okay, x equal to L, the length will be equal to n lambda by 2. Okay, and for x equals to 0, at this position we will have first node, and for x equals to L we will have next node. Okay, here we have first node, and at x equals to L we will have next node for fundamental frequency. This is for fundamental frequency. Okay, for if you keep n equals to 1, L equals to lambda by 2 for fundamental frequency. Okay, and we know that nu equals to v by lambda. And from this equation, the equation L is equal to n lambda by 2. Lambda is equal to 2 into L by n. Right? If you substitute in this equation, I consider this equation as number 3 and this as number 4, substitute equation 4 in 3. Therefore, the frequency nu is equal to v into n by 2L. V by lambda kada. So if you substitute the lambda value in this equation, we will have the frequency as n into v by 2L. Okay, for n equals to 1 you will have fundamental frequency, and for n equals to 2 you will have first harmonic, and n equals to 3 second harmonic, third harmonic, and so on. And for the fundamental frequency, for n equals to 1, the fundamental frequency will be equals to V by 2L. And for n equals to 2, you will have the first harmonic as n equals to 2V by 2L. V by 2L is nothing but nu1, therefore nu2 will be equal to 2 nu1. Okay, and then after you will have 3 nu1, 4 nu1 and so on. Higher frequencies at which the stationary waves are formed. And these are related, the frequencies are related with each other as 1:2:3 so on. Nu1, 2 nu1, 3 nu1, 4 nu1 and so on. Okay, these are the frequencies at which harmonics are formed. And using the fundamental frequency equation, I am going to deduce the laws of transverse waves in a stretched string. Okay, and we know that the transverse wave, the velocity of a transverse wave, will depends on inertial properties and restoring force. Velocity of a transverse wave in any medium always depends on inertial properties as well as restoring force, but the medium here is a stretched string, and the restoring force for the stretched string is tension. Tension is the restoring force here, and inertial properties is the linear mass density. For a stretched string, inertial property is the linear mass density, which is denoted with mu. And the velocity of a transverse wave, will be equal to square root of T by mu. I had already derived this equation in our previous classes. You just go through the playlist of waves chapter for this derivation. Okay, and you just observe this equation and this equation. This is number 5 and 6. Okay, substitute equation 6 in fifth equation. Substitute equation 5 in 6. Solve this. You just substitute that. Substitute the velocity v equals to square root of T by mu in nu1 is equal to v by 2L. Substitute cheyandi. And finally you will have the relation for the frequency nu1 is equal to 1 by 2L times into what is v, we have square root of T by mu. Using this equation we are going to find out the laws of transverse waves. Okay. మనం ఏం చేసాం, ఫండమెంటల్ ఫ్రీక్వెన్సీ రిలేషన్ తీసుకున్నాం అండ్ వెలాసిటీ రిలేషన్ తీసుకున్నాం. ఓకేనా, వెలాసిటీని ఫండమెంటల్ ఫ్రీక్వెన్సీలో సబ్స్టిట్యూట్ చేసి అక్కడ నుండి మనం లాస్ ఆఫ్ ట్రాన్స్వర్స్ వేవ్ డెడ్యూస్ చేస్తున్నాం. ఓకే, లెట్స్ సీ. అండ్ ఫస్ట్ లా ఫర్ ట్రాన్స్వర్స్ వేవ్. ఓకే, and we know that the frequency is equal to 1 by 2L times of square root of T by mu. Okay, whenever the tension in the string and the linear mass density are constant, then the frequency of the wave will be directly proportional to 1 by L. 1 by L are inversely proportional to the length of the string. Whenever the tension in the string and the linear mass density are constant, then the frequency is inversely proportional to the length of the string. This is first law. And coming to the second law, we have three laws. And coming to the second law, what is the second law? Whenever the length and linear mass density, the length of the string and the linear mass density of the string are constant, then the frequency is directly proportional to square root of the tension in the string. This is second law. And coming to the third law ఏంటి మీరు చెప్పండి? Whenever the tension in the string and the length remains constant, then the frequency is it is inversely proportional to the square root of the linear mass density. These are the three laws for transverse wave in a stretched string. Okay, I will end our lecture here itself. And whoever didn't subscribe to my channel, please subscribe, like and share with maximum number of people. మీ ఫ్రెండ్స్కి అవసరం ఉంటే ఇక లెక్చర్స్ ఎవరైతే ఫెయిల్ అవుతారు అనుకుంటారో వాళ్ళకి డెఫినెట్గా ఈ లెక్చర్స్ అవసరం, ఇంపార్టెంట్. ఎందుకంటే నేను ఓన్లీ ఇంపార్టెంట్ క్వశ్చన్స్ లిస్ట్ మాత్రమే ఎక్స్ప్లెయిన్ చేస్తున్నా, కంప్లీట్ చాప్టర్ ఎక్స్ప్లెయిన్ చేయట్లా. నేను ఎవ్రీ సండే 1 షాట్ లెక్చర్ తీసుకుంటే అక్కడ కంప్లీట్ చాప్టర్ ఎక్స్ప్లెయిన్ చేస్తాను. ఓకేనా? ఫస్ట్ మనకు మెయిన్లీ ఇంపార్టెంట్ క్వశ్చన్స్ ఎక్స్ప్లెనేషన్ అయిపోయిన తర్వాతకి కంప్లీట్ టాపిక్స్ పైన ఫోకస్ చేద్దాం. ఓకేనా? బాయ్.